My project is the synthesis and characterization of alkali antimonide photocathodes, specifically looking at sodium-potassium antimonide films. A photocathode emits electrons once light hits its surface via the photoelectric effect, and our goal in the Phoebe lab is to grow photocathodes with a high quantum efficiency, QE, and a low mean transverse energy, MTE. Quantum efficiency is the number of electrons emitted per incident photon. Alkali antimonide films are already well known for their high QE, which is why we choose to use these materials. MTE is the momentum spread of the emitted electrons. With a high MTE, the electrons are being emitted in different directions, whereas with a low MTE, the electrons are being emitted in the same direction, which improves the brightness and effectiveness of the beam. We believe that flat and ordered films will help lower the MTE. This picture shows the diagram of the molecular beam epitaxy, or the MBE photocathode system. In the MBE chamber, we are measuring the QE at one singular wavelength around 530 nanometers during the growth. The picture on the right shows what happens in the MBE chamber during the growth. The light hitting the substrate helps measure the QE as well as the sources in blue and orange depositing onto the substrate. We have 3 deposition methods. Co-dep is when all the sources are open at the same time. Sequential is when one layer of a source is deposited at a time. And 2-step provides a more controlled growth, allowing us to choose when the shutters open and for how long. Once the growth is completed, we transfer the sample to the storage chamber to take the spectral response, where we measure the QE at wavelengths from 400 to 700 nanometers. We also look at the RED, which stands for Reflection High Energy Electron Diffraction, to monitor the crystallinity of our samples. The electron gun hits the film and diffracts onto the screen to show crystal patterns. We ideally want flat single crystals like the one circled, as we believe that will lower the MTE. In the end, many sodium-potassium antimonide samples were grown on silicon and silicon nitride substrates that showed high QE and green light and ordered but rough RED images. The Phoebe lab will continue to experiment with parameters to increase the QE as well as smooth out the films.